Hello everybody. So this video is about how do you take the derivatives of trig functions. So I've had just hundreds of students emailing me like, Boris, I'm really enjoying derivatives. Can we take the derivatives of my favorite functions, sine, cosine, even cotangent or secant or something cool like that? And that's what we're going to get today. And I want to start with yesterday's lesson. Yesterday's lesson is about drawing the derivative of a function. Okay, so in this case, I've graphed sine of x. So I'm using the same app that I shared with you, and I'll post it again here. There's sine of x right there. This is a graph of sine, right? So what I'm going to do is I'm going to sketch out the derivative, and we're going to see what that looks like. So look at what happens as we get closer to 0. So at the origin here, we have a slope of 1. We have a tangent line with a slope of 1. So we graph it out, it has a slope of 1. And now as we keep going, we're going to get towards a slope of 0. So that's the original function in red, and it's drawing the derivative here in green. And after we have a slope of 0, now we get to a slope of -1, and then a slope of 0 again, and then a slope of 1, and then 0, and then -1, and it keeps repeating. So the red was sine. What is that green graph? The derivative is sine. Well, what looks like sine but starts with max? It's cosine. Oh. So by graphing this, we can see that the derivative of sine is cosine. Okay, and then let's do something else. Let's start with cosine of x. So there's cosine of x in red, and now we're going to look at what the derivative of that looks like. So again, getting to the origin, we start with a slope of 0, but then we go down, and we have a negative slope of 1, and then it gets back to a slope of 0, and then a slope of +1, and then 0, -1, and so forth. So now we ask ourselves, well, what is that green graph? It's not sine, because sine starts the origin and goes up, but it's negative sine, because negative sine starts the origin, goes down, and then has these same patterns. So that tells us the derivative of cosine was negative sine. Okay, so let's go back over here. So what I'm going to do now is set up a table in my notes. We're taking the derivatives of trig functions. And we got these from looking at kind of the graph, that the derivative of sine was cosine x, and the derivative of cosine was negative sine. If you really love all those random trig formulas from Algebra 2 trig, you can prove those using that and limits as well. Okay, but now you're thinking, how do I take the derivative of secant of x, or cosecant of x? Okay, so what we're going to do to find these other derivatives, and you don't need to memorize the procedure. This is something that you just need to, okay, what's the derivative of secant? It's blank. As long as you know that, you're fine. But if you forget, it's good to be able to come up with it again on your own. So what we're going to do is we're going to write it in terms of sine and cosine. And then we're going to use the quotient rule. So let's say we have f of x equals secant of x. So I'm going to write that as 1 divided by cosine of x. Okay. So how do we take the derivative of 1 over cosine? Well, it's a fraction. So I'm going to leave myself room for this table. When I take a derivative fraction, so I do low d high. So cosine x, derivative of 1 is 0. Cool. Minus high d low. And the derivative of cosine is negative sine. Okay. And this is square the bottom. Away we go. Okay. So what I'm going to get is I'm going to get negative, well, actually positive sine of x over cosine squared of x. Usually we try and write these as kind of a product. So I'm going to split this up and write it as sine over cosine times 1 over cosine, which I can write as tangent x times secant x. Okay, cool. So what that shows is the derivative of secant is tangent x times secant x. Okay, and that's usually the form we're going to use instead of the sine over cosine squared. So when you do cosecant, I'm not going to do it. You could do it on your own. If you want to pause this video and do the same thing with cosecant, you can. The derivative there becomes negative cotangent x cosecant x. One thing you'll notice, the derivative of all the c's, those turn out to be negative, by the way. So that's a way you can help remember these. Okay, so let's look at one more. Let's talk about tangent and cotangent, what those derivatives are. So let's say now we have tangent x. You hopefully remember you could write tangent as sine over cosine. So now let's go ahead and use the quotient rule on that. So my first derivative there, I'm going to use quotient rule. So low d high, derivative of sine is cosine, minus high d low, derivative of cosine is negative sine. Square the bottom, away we go. Okay, so what I'm going to have, what I'm going to have here is I'm going to get f prime is cosine squared x minus minus, so plus sine squared x over cosine squared x. Okay, now again, let's go ahead and figure this out. What is cosine squared plus sine squared? Okay, so cosine squared plus sine squared, that's equal to, oh, that's always 1. That was one of those famous formulas that we learned back in Algebra 2 trig. So that's always 1, so this turned out to be 1 divided by cosine squared x, which we could write as 1 over cosine x squared, also known as secant squared of x. Okay, so let's go ahead and take that result, the derivative of tangent with secant squared. We'll write that up here. The derivative of tangent being secant squared x. The secant tangents stick together. Again, if you want to pause this video and do the same thing for cotangent, you can. And just kind of figure it out. Cotangent, you know, is cosine over sine. You do that derivative. You'll see that one ends up being negative cosecant squared of x. Okay, make sure that you take the time to memorize these 6 at some point or be able to quickly derive them. We're going to take trig derivatives throughout the year, and it's something I really want you guys to feel comfortable with and feel like you understand what's going on. Okay, the only other thing I want to tell you, I wanted to give you like one quick trick. Don't forget about kind of your trig formulas. So kind of a trick might be, to try to simplify before taking a derivative. This is not something you're always able to do before you take a derivative. But for instance, if I give you like y equals, say, sine of x times 1 plus cosecant of x, or if I give you y equals, what was the example I wanted to do here? Okay, secant x times cotangent, times cotangent x times sine of x. Okay, now you can do the, you could do these, but this is kind of like product rule hell in some cases. So I want to encourage you to see if there's a way to simplify. So if you distribute this out, you get y equals sine of x plus sine of x times cosecant of x. But you might remember that cosecant is 1 over sine. So before you even take a derivative, you could rewrite this as sine plus cosine. On the second function, if you write everything in terms of sine and cosine, this is like 1 over cosine times cosine over sine times sine, and then you recognize actually this is just some pervert's way of writing 1. So the derivative, of course, is 0. So you can sometimes save yourself time like that. Okay, most of your homework tonight is just going to be doing product rule, quotient rule, writing equations for tangent lines like you've been doing, using trig functions, you know. So if I give you, for example, something like y equals x to the 4 times secant of x, and I ask you to find dy dx, well, that should be straightforward. We're just using all our old rules, the product rule and the quotient rule, just this new derivative. So we know that my derivative dy dx is the first times derivative of secant, which is negative secant times tangent, plus the second, which is secant, times derivative of x to the 4, which is 4x cubed. Okay. So that's what your homework should be tonight. Pretty straightforward. Just working with these trig derivatives. Make sure you memorize these trig derivatives. And if you don't already, make sure you go back and remember the unit circle. You're going to need it. You know, I should be able to just tell you, like, what's cosine 2 pi over 3? And you should be able to tell me, like, bruh, it's negative 1/2. So, okay. Have fun. Hope this helped. And as always, let me know if you have questions. I'll see you soon. Oh, wrong button.